All right, so this is Math 1314, sections 1503 and 1505. I guess I should write that up here. 1503, 1505. So welcome. For those of you who are watching the recorded version, I've just briefly talked about the stuff that's on the screen right now. We're going to go ahead and get started. I do want to remind everybody about registering in Remind and in WebAssigned and get those things taken care of. Remind is how I'm going to be sending out most of the notifications during the semester of things that are going on. And WebAssigned is obviously how you do your homework, and you don't need to get behind on that. Last semester I had students who took a long time to get started on WebAssigned, and then they got behind and they really had trouble catching up during the semester. So I want to kind of point that out and make sure that you keep up with your WebAssigned homework. So get started on it now. There's a grace period. So even if you don't have the money to pay for the access code for WebAssigned right now, you can still register and get started on your homework on that. And I would strongly recommend you do that. All right, so I'm going to flip the screen now, and we're going to talk a little bit about what we're going to do and then get started. So first of all, so since this is college algebra, what is college algebra? And as far as the way we teach it at North Harris, and how does it differ from intermediate algebra? So what we're going to do is we're going to start off by looking at equations and inequalities. So we're going to look at equations and inequalities first of all. And we're going to start off today by looking at quadratic equations. But we're going to look at other types of equations also, some that you have seen before, possibly in intermediate algebra, but definitely some that you have not seen, the kinds of equations we're going to look at and how to solve them. And so we're going to, that's kind of an introductory topic. Those are all things we need for the rest of the semester. And so I want you to kind of, that's important material, but it can be a little bit rough for people at the beginning. I'll tell you right now that in college algebra, frequently that beginning material sometimes causes people a little bit of grief, and then if they can survive that, then they're okay the rest of the semester. But it's something that's, some of that is going to be things that you haven't seen before, or it's been a long time since you've seen before, and so you're going to have to work hard on that stuff at the beginning. It's really important to get a good start in college algebra. And then after we deal with all this stuff with equations and inequalities, that's going to just take us 3 or 4 days to get through that stuff in class. Then we're going to move on to talking about functions. And so if you guys just pause for a second, I need to send a text to somebody here who just logged on, who doesn't have their audio set up. So hold on just for a second. I'm going to send a text. All right, so getting back. So we're going to talk about functions. So we'll do an introduction on what a function is again. You did cover that in intermediate algebra possibly, but I'm going to assume that you do not know what a function is going into this. And so we're going to start from the beginning, and we're going to cover a lot of basic stuff about functions, but then we're going to go from there and do a lot of stuff with graphing functions, different kinds of functions, different kinds of graphing skills, lots of things that you've not seen in intermediate algebra. Then after we do the introductory stuff on functions, then we will look at some specific types of functions. And we will talk about, a big class will talk about our polynomial functions. And spend a lot of time talking about polynomial functions. And then we'll deal with rational functions. And then exponential functions. And then logarithm functions. That is really the heart of this class, are those 4 topics right there. And that's going to take us, for polynomial functions, rational functions, exponential functions, logarithm functions, that's going to take us probably half the semester or more to get through that material. And that's going to take us quite a while to get through that. There's a lot to do with all four of those different types of functions. And then we will finish the semester by doing a little bit of an introduction to using matrices to solve systems of equations. Now, there's other things that I'm not listing here, certainly, that we've got to talk about as we proceed on through here. But this is the kind of the bulk of the class here. This is what we've got to talk about during the semester. And this is how we're going to kind of proceed through the semester. So this kind of gives you an outline of what we're going to be covering for the semester. One other thing I want to mention is calculator usage. We will be using calculators during the semester. I will be bringing in graphing calculators. When I say bringing them in, I'll actually show a graphing calculator on the screen some, and we'll look at some graphs. We'll definitely look at lots of graphs in various different places and use that to our advantage. I will allow you to use a graphing calculator on exams. I will encourage you to use a graphing calculator on exams in a few places, certainly. And now, it doesn't mean necessarily that you have to go out and buy one. There are apps, there are free apps that you can use on a smartphone or on another device that you're using to allow you to do the graphing that you need. But on an exam, you'll probably want to have a graphing calculator with you. Most testing centers have graphing calculators available for you to borrow. So we'll talk more about that as we get closer to the first exam, but I will use calculators during the semester relatively often, actually, in various different places. So definitely kind of be ready for that a little bit. All right, so that's kind of an overview of the semester, what we're going to be covering. And so now that we've kind of gone through that today, what we are going to be doing is looking at section 2.5, and we are going to review. I'm looking at this as a review of solving quadratic equations. And so that's what we're going to be covering this semester today. And so in order to talk about quadratic equations, the first thing is, what the heck is a quadratic equation? I want to make sure that you know how to pick one out from a crowd when you see it. And remember that a quadratic equation in general is a second degree polynomial equation. So what that means is that it's got to have a second degree term in it. It's got to have an x squared in it. And so the general form for a quadratic equation looks like this. The ax squared plus bx plus c equals 0, where a is not equal to 0. So that a not equal to 0 simply means that this term is the term that must be in the equation in order for it to be quadratic, is the ax squared term. There's got to be a squared term in there, and no term higher than a degree higher than 2. So make sure that you can pick out a quadratic equation when you see one. So for example, this equation right here, which looks kind of nasty, this equation right here, 2 plus 3 times 3x plus 1 minus 6 equals 8 plus 3 times 5x minus 6. This is a linear equation. This is not quadratic, because when you multiply this out, when you get rid of all the multiplications, right, use the distributive property here, right, to get rid of the parentheses. Please don't add the 2 and the 3 together, because remember, if you add the 2 and the 3 together right there, you're violating order of operations, right? Because the multiplication's got to come before the addition. Equals, and then the same on the other side of the equation. On the right side, don't add 8 plus 3, because multiplication comes before addition. So this would be 8 plus 15x minus 18, like that. This is a linear equation because look at, when you get rid of all the multiplications in there, all you have are linear terms or constants, right? There's only first degree terms in here. So this is a linear equation. So this is linear, not quadratic. It's first degree equation, right? It's a first degree equation. I assume that you can solve linear equations. So this equation right here, you know, if you're watching this at home later, you might want to stop the recording and say, okay, can I go through and solve this equation on my own without him helping me, right? Going through and multiplying everything out would be the first step, like I just did right there, but then you need to be able to solve this equation on your own. So I'm going to, instead of pausing and letting everybody see if they can do this, I'm just going to walk through the steps. But what I'm hoping is, for those of you who are watching me live right now, I'm hoping that you're working ahead right now with your paper and pencil. And you should, if you attend live, or if you're watching this recorded, you should always, you know, I can't see into your rooms. I don't know where you are. I don't have any video set up in your room. And I'm not going to have, you know, when the video works, I'm just going to want you to see me. I'm not going to see you at all. So you could be, you know, eating potato chips or sleeping, or you could be, you know, doing the laundry. You could be doing all sorts of different things. I want you to have a piece of paper and a pencil or a pen or something with you when you're watching these videos or when you're here live, so that you can be taking notes just like you would in a regular class, and sometimes be working through problems that we're talking about in class, maybe working a little bit ahead of me. And so I want you to be able to do that. This particular problem, you know, hopefully you've got paper and pencil out and you're kind of working ahead to see if you got this. But next thing we would do is collect like terms. So I have 9x, and then 2 plus 3 is 5. I'm collecting like terms. Minus 6 is minus 1. So on the left side of the equation, you have 9x minus 1. And on the right side of the equation, you have 15x minus 10. 8 minus 18 is negative 10. And then you would subtract 15x from both sides of the equation, and you get negative 6x minus 1 equals negative 10. And then you'd add 1 to both sides of the equation. You get negative 6x equals negative 9. And then divide by negative 6, and you get x equals negative 9 over negative 6, or positive 3/2. And so 3/2 would be the solution to this equation, provided I didn't do anything careless and make an arithmetic mistake somewhere in there, which hopefully you're going to always be checking me on. That is something I assume you can do already. And so this is not the, you know, what we're talking about in class. I assume you can do this with no problem. You know, so if you just need a little bit of practice, that's one thing. But if you're really struggling with linear equations, that's going to be a problem for college algebra. And I think probably most of you are okay with solving linear equations. That's not something I'm going to worry about too much. What are we looking at? We're looking at quadratic equations. So now quadratic equations are second degree equations, just like I said on that previous screen. And so some examples of quadratic equations might look like this. You know, so like 2x squared plus 5x minus 3 equals 0 is an example of a quadratic equation. Notice that equation is in standard form. Ax squared plus bx plus c equals 0. It's already in that form. But an equation doesn't have to be quadratic, or I'm sorry, it doesn't have to be in standard form to be quadratic. So this equation right here, well, that's a quadratic equation also. It's not in standard form, but it's certainly quadratic, because if you multiply all that out, right, use the FOIL method on the left side, you get a squared term, right? When you multiply it out, you get 8x squared And then the outside 2 is plus 2x. The inside 2 is minus 12x. The last 2 is minus 3 equals 6. Then see, you've got that squared term in there. So you know it's quadratic. Now you would want to probably put this in standard form. So you get 8x squared minus 10x, collecting like terms in there. And then subtracting 6, you could put it in standard form like that. And right, and that quadratic equation, when you see one, and say, starting in the problem, you go, okay, I know this thing's quadratic. Now, what we're going to look at here for the next, let's see, so for the next 30 or 40 minutes, we're going to look at a quick review of all the different ways to solve quadratic equations. So the methods for solving quadratic equations, there are 4 methods, basically. There's the factoring method, which uses this idea that when you take 2 numbers and multiply them together, a times b equals 0, that it's got to be true that one of the numbers has got to be 0. So the factoring method is a method for solving quadratic equations. Using the idea that when 2 numbers multiply to give 0, one of them has got to be 0 in order for it to be true. But the factoring method doesn't always work. And so we also have something we call the square root method. And sometimes you'll see that referred to as the extraction of roots method, which sounds too painful to me, so I don't ever call it that. It sounds too much like a dentist visit. But you'll see sometimes the extraction of roots used for that particular method. I call it the square root method. That also doesn't always work. And then the third method is kind of the square root method, but it involves something called completing the square. Now, completing the square always works, but it's not necessarily always practical to use, and it's not a method that we typically use for solving quadratics. We do use it for other things, but not for solving quadratics. So it is something we're going to talk about today, but it's not something we're going to use until later, probably in a more regular fashion. And then finally, the last method is using the quadratic formula to solve a quadratic. So now I'm expecting, and if you're with me right now live, or if you're watching this later, you're going to notice that I'm going to go through this pretty fast, these 4 methods. And the reason why I'm going through it pretty fast is because I'm assuming that this is a review for all of you and that you've seen these methods before. Now, maybe you kind of have forgotten some things, or maybe it's been a while and you just need to knock some rust off, but I'm assuming that these are things you can do. And so you're going to see me proceed through these pretty fast. Don't judge the rest of the semester based on that, because when we're covering material that I feel like is new material, we're going to take our time and we're going to go through it very methodically and in detail, okay? So, but hold on, because we're going to go through this stuff pretty quickly overall. All right, so and please, as I'm going through this, if you have any questions at all, if you don't understand something that I'm talking about, you stop me. Don't. If you're watching live, don't worry about shouting out and asking me a question. I have no problems stopping and going back over something again and addressing any concern you have. Okay, so please don't hesitate to stop me. All right, so we are going to start off by using the factoring method. Now, the factoring method, unfortunately, does require that you remember how to factor polynomials. But so as we go through the factoring method, you'll do some reviewing of factoring as well. All right, so the first equation, we have 2x plus 3 times 3x minus 5 equals 0. This is quadratic. Remember, we talked about this before, because if you multiply this out, you do get a squared term. But this is an equation where you don't need it in standard form, and the reason why you don't is because it's in this nice form, a times b equals 0. And remember that the factoring method does require that you have an equation in the form a times b equals 0. All right, in other words, two numbers multiplied together, you've got to have 0 on one side of the equation. So if the equation's already in that form, like this one is, then all you're doing is using the fact that, hey, the only way that that can be true is if one of the two numbers is 0. And so you just simply set each factor equal to 0 and solve both of the equations. So super easy, once it's in that form, super easy to solve it, because you're just setting each factor equal to 0 and then solving each of these equations, right? So subtract 3 on the first one, add 5 on the second one, and then divide by 2, and then here you divide by 3. And really straightforward, right? And now when I solve equations, since I'm finding a set of numbers, I usually put that set in set braces at the end. You know, if you didn't do that, it's not something I'm going to penalize you for, but it is a good habit to get into, to go ahead and write the solution set in braces at the end like that, because you're talking about a solution set. And remember, those are the numbers that we're saying make the original equation true, right? And you could always check both of them and substitute them in for x, which we're not going to walk through on most of these, but sometimes we will. You could actually check to make sure that your solution actually works. All right, so that's a simple example where we're using the factoring method where the expression was already in factored form. So that was nice. This next equation looks a little bit different, but it's really the same thing. That this one's already in a nice little factored form. It's already in a multiplication form, and so and it's set equal to 0. And so all we need to do is set each factor equal to 0, right? And we can solve this equation easy. Now, don't freak out on the 7x equals 0. You know, that looks a little bit differently, but you solve that just like any other equation. You divide by 7 on both sides, and you get x equals 0, right? 0 divided by 7 is 0. There's nothing wrong with 0 being a solution to an equation. On the second equation, add 7 and divide by 2, and you get 7/2 as a solution set. And so the solution set is 0 and 7/2 right there. Nothing wrong with 0 being a solution to the equation, okay? All right, very straightforward, no big deal on any of those. Now, if the equation's not in factored form, then you've got to be able to factor it and put it in that factored form. So let's say we have an equation that looks like this one, 12x squared minus 20x equals 0. 12x squared minus 20x equals 0. So that's a quadratic equation, but it is not in factored form. It's not a multiplication problem. And so since this is not a multiplication problem, we have got to be able to write it as a multiplication problem so we can solve the equation. All right, so, and don't forget that the first thing you always do when you factor a polynomial is you look for a GCF, right? And so the GCF on this equation is 4x, right? You can take out a 4x right there. And you're left with 3x minus 5 when you take out that 4x. Right, and so that equation now is written as a multiplication problem. And so now it's like the first two. And so now you can just set each factor equal to 0 and solve both of those equations. So 4x equals 0, you divide by 4, you get x equals 0. The second equation, you add 5, divide by 3, and you get 5/3 as the solution. And so the solutions to this equation are 0 and 5/3. All right, so here, what do we have? We had a quadratic equation. We identified it as quadratic because of the squared term right there. And as soon as we see a quadratic, we know that if we can write the equation as a multiplication problem equal to 0, right? It's got to be equal to 0, remember. But if it's a multiplication problem equal to 0, then it's an easy equation to solve. So that's what we proceed on to try to do. to write it as that multiplication problem. All right, so the next problem I want to look at, let's say we have x squared minus 5x plus 6 equals 0. All right, so x squared minus 5x plus 6, that equation is quadratic, right, because of the squared term. So it is a quadratic equation. It's not written as a multiplication problem. It is set equal to 0, but it is not a multiplication problem. And so we can write it as a multiplication problem, though, because this is a relatively easy trinomial to factor. Remember, with a trinomial, you're always trying to get that middle term to work out correctly. And here you've got x's as first terms of the two binomials, and the second terms of both binomials have to multiply to give positive 6. You're just trying to get that negative 5 in there. And so if I put a minus 2 and a minus 3 in there, and hopefully most of you who are following me right now live, you're looking at it and you had already factored it in your head or on a piece of paper, and you knew how it was going to factor because that's a pretty easy one, right? The inside 2 is negative 2x. The outside 2 is negative 3x, and those add to give negative 5x, right? Which is what you're trying to get is that middle term. So we have it factored correctly. It is now a multiplication problem. And so now we can set each factor equal to 0. Right? We know that that's the only way that that equation could be true is if one of those factors was 0. And so we get x equals 2 and x equals 3. When we solve that, very easy to solve from there. And you get 2 and 3 as a solution. Okay, once again, that should be pretty straightforward. And remember, you need to go back and probably do some reviewing on factoring, but that hopefully worked out pretty well. Now, the factoring won't always be quite as simple as what we saw in that particular problem. So, for example, if you have this equation right here, let's say you have 8x squared minus 24x plus 16 equals 0, like that one. So it's certainly quadratic, right? The does have a squared term in it. It is set equal to 0. So it's all set up to be a problem where we can use the factoring method to solve it. We just need to write the expression as a multiplication problem. So the first thing we do is we take out a GCF. Remember, the GCF is always the first thing you look for. And in this case, there is a GCF of 8. So you can take out that 8. And you're left with x squared minus 3x plus 2. And then you're left with a pretty easy trinomial to solve, to factor, and that factors x minus 2 times x minus 1. That does give you that negative 3x as the middle term if you try to check it. All right, now in this particular case, when you set factors equal to 0, the 8 is a constant. So since it's a constant factor, it can't be equal to 0. Right? There's no way that that can be equal to 0 because it's equal to 8. And so when we set these factors equal to 0, we can ignore that 8 altogether because it's not going to give us a solution. If you want to, you could certainly divide both sides of the equation by that 8. It's always okay to divide both sides by a non-zero constant. So if you wanted to divide both sides by 8, you could do that and make it go away altogether. I just usually just look at it as that if it's a constant factor, it's not going to give me a solution there and I can ignore it. All right, and then you solve each of these resulting equations. When I set the factors equal to 0, it's pretty easy to solve from there. And you get 2 and 1 as solutions like that. All right, so that looks pretty straightforward. The next problem I want to look at, I'm working through examples right now to kind of illustrate the different methods that we're looking at. So the next problem we have 8x squared plus 6x minus 9 equals 0. Now this problem's also set equal to 0. So it looks, that part's set up right. It's certainly a quadratic equation. There is no GCF here. So this one's a little bit more involved as far as factoring. right? So it's a little bit harder of a trinomial to factor. We do know that there's an x in the first terms. And remember, these inside two terms and these outside two terms have to combine to give us that plus 6x. We know that the factors of 8 are 1 and 8 and 2 and 4. And we know the factors of 9 are 1 and 9 and 3 and 3. We don't worry about the fact that it's a negative 9. We'll worry about the signs in a minute. And so we're trying to somehow get a 6 out of that, right? And so if you notice, you can pick the 2 and the 4 and the 3 and the 3. If you do that, you have a 2x and a 4x like that. That gives us the 8x squared we need. We can put the 3 and the 3 in. That gives us the 9 that we need. This gives us a 6x on the outside and a 12x on the inside. See, and we can make the signs work out. Since it's a negative 9, we know one of those terms has to be positive and one has to be negative. And so we want the 12 to be positive and the 6 to be negative there to give us a positive 6. So that means we have a 2x plus 3 and a 4x minus 3, like that is our factorization. And that will work out just fine. And these middle two terms, the 12x and the negative 6x, those will add to give me that positive 6x as the middle term. So some of you may need to go back and do some reviewing on factoring like that. Now, the factoring isn't going to be horrible as we go through the semester, but you are going to have to be able to factor polynomials, so and trinomials like that. So, you know, you just need some practice on that because it'll come up throughout the semester in various different places. Like I said, nothing too terribly difficult, but it is going to come up. And then solve each of these equations after you set these factors equal to 0. That's the easy part to the equation, and you get negative 3/2 and 3/4 as solutions, like that. All right, so I think we're doing okay. A couple of other things to talk about here. So let's say we have this equation. We're almost through with the factoring method. Let's say we have 2x squared equals, equals, I'll get this right, 2 times 18 minus 7x. Like that. All right, so now that's obviously a quadratic equation, but this is not set up to use the factoring method because it's not set equal to 0. So it's not set equal to 0. So if you're going to try to use factoring here, it's got to be set equal to 0. And so this is a bad form right here, like we've got it. So first thing you do is multiply everything out. Like that, get rid of all the grouping symbols, and then move all the terms to the left side of the equation, right? Like this, and then set it equal to 0, right? And this one is set equal to 0. That's what you want at the beginning if you've got a quadratic equation and you're trying to use the factoring method. And same thing with the quadratic formula as well. And then you proceed on with factoring from here. You could take out a 2, like that, and so that common factor, and then factor that trinomial, and that factors x plus 9 times x minus 2, like that. So it works out pretty easy from there, but you have to make sure that you take the time to set the equation equal to 0. So you end up with x equals negative 9 and x equals positive 2. So negative 9 and positive 2, like that. All right, so that should work out pretty well. All right, so we're doing well on the factoring method. One last problem on the factoring method before we do anything else, before we move on. Make sure that we have a good overview of everything that's going to happen with the factoring method. So let's say we have this equation, 16x squared minus 49 equals 0. Now that's not a trinomial. There is no common factor there, but that is the difference of two perfect squares. And remember that the difference of squares, a squared minus b squared, factors a plus b times a minus b. And so, sometimes a quadratic will factor as two perfect squares like this. And so we can factor this particular equation as 4x plus 7 times 4x minus 7. And again, if you're a little rusty with factoring polynomials, that might be something that you kind of have forgotten about a little bit. But don't forget to look for a square minus a perfect square minus a perfect square as a possibility. And then you set each factor equal to 0. Then from there it's easy. And you end up with negative 7/4, and you end up with positive 7/4. Like that. And so those are my solutions, negative 7/4 and positive 7/4. All right, so you guys have been pretty quiet who are listening live today. Any questions about the factoring method? A very fast rundown on the factoring method. Anybody have any questions on the factoring method at all?
I'm good.
All right, Charlotte.
I'm good.
Justin sounds.
Yes, sir.
Justin sounds good. Anybody else have a question? All right, then let's move on. Let's talk about the square root method next. And the square root method is going to bring up several things that we need to talk about. The square root method involves having the equation look like this. Remember, this is a method for solving quadratics. But if you have the equation like this, it's in this form. Something squared equals a constant. And that something may be some variable expression. So sometimes I'll write it like this. Bob squared equals a constant, right? Where Bob is some variable expression. If you have a quadratic that happens to be in that nice special form like that, then the square root method is a method that you can use to solve the equation, and where you don't have to rely on factoring or anything like that to solve the equation. So for example, if we have x plus 6 squared equals, let's say, 81, right? That equation is in the form something squared equals a constant. Bob squared equals a constant. And when you have an equation like that, the easy way to solve this is to simply take the square root of both sides of the equation. Now, when you take the square root, you do have to account for the fact that there are two numbers you can square to get 81. There's a positive number you can square to get 81 and a negative number you can square to get 81. So when you take the square root of both sides, first of all, the square root of x plus 6 squared, as long as x plus 6 is positive, the square root of x plus 6 squared is just x plus 6. And then on the other side of the equation, you're taking the square root of 81. But again, you have to take into account that there could be two solutions, or there are two solutions to an equation like that, both a positive one and a negative one. So you have to put in that plus or minus. Very common to see students forget that plus or minus. So I'm going to kind of really point that out, that you have to make sure you include that. You have to include both solutions when you're solving using this method. Now, the square root of 81 is something we happen to know. That's just 9, so you just get plus or minus 9 right there. And then you solve this equation for x. And to solve it for x, you just subtract 6 from both sides. So you get x equals, and I'm always going to put the negative 6 at the beginning on a problem like that, and then write plus or minus 9 to emphasize that that's both addition and subtraction right there. Please don't leave it like that. If you're solving this equation, this is something I would penalize you for right here, because you're just kind of being lazy. If you can, you don't want to leave it like this. If it's something you can simplify, if it's something you can finish out, this is arithmetic you can do. So you definitely finish this out. Don't leave it in that form. If you can't do the arithmetic, that's one thing. But this is one where you can do the arithmetic, right? It's x equals negative 6 plus 9, which is 3. And x equals negative 6 minus 9, which is negative 15. So you get two solutions there, 3 and negative 15. And those would both be solutions to that original equation, right? These are both going to make this original equation a true statement. All right. So that's how we're going to solve using the square root method. Now there's definitely complications to that little process that we definitely need to address. So for example, in this equation right here, you have 2x plus 5 squared equals 20. It is in the form something squared equals a constant, but now the constant's not a perfect square in this problem, so there's a little bit different the way this is going to work out at the end, a little bit more that we're going to have to do with the radical. So you take the square root of both sides of the equation. Don't forget the plus or minus, right? That plus or minus you got to keep in there, so don't forget that. But the square root of 20 simplifies. Now, to review that just for a second, and again, the simplification we're going to do here with these radicals is not probably nearly as messy as you would have seen in intermediate algebra, but it is something you need to know how to do. So square root of 20, don't leave it as the square root of 20. Don't write it as a decimal approximation unless we're looking at some kind of a graph where we need a decimal value for it so we can graph it. Here we're going to write the exact solution, but we're going to write it in as simple a form as we can. So remember that square root of 20, the way you do that is you break it up as the square root of 4 times the square root of 5, and so that'd be 2 times the square root of 5. And so that is what we consider the simplified version of the square root of 20 because the number underneath the radical is now smaller. And so write it as 2 times the square root of 5, right? Don't leave it as the square root of 20. And then subtract 5 from both sides. And see, now this is arithmetic you can't do, right? Unlike the last problem, I can't add that negative 5 to the 2 square root of 5 because one's a radical and one's not. So you don't do anything there. You just leave it as negative 5 plus or minus 2 times the square root of 5. And please don't write it this way. It's not wrong, but it's just not good form here. Don't write plus or minus 2 square root of 5 minus 5 like that. And the reason why is because that 5 at the end, it's hard to know whether that's underneath the radical or not under the radical. But if you put it out front, there's no question that it's not under the radical, and that's the way I'd rather you write it. And then you divide by 2 to solve this equation, and for x finally. And you have negative 5 plus or minus 2 times the square root of 5 divided by 2. Now, a word about simplifying numbers like that, because you're frequently going to have numbers like that one to simplify. The only time you can divide out that 2 is if that 2 is common to all the terms. So if you had an equation like this, let's say you had negative 10 plus or minus 2 times the square root of 5 over 2. So do you see how the 2 is common to all of those terms, all 3 terms? And so you can divide out the 2 because it's going to be a common factor in the numerator and the denominator. And so I can divide out the 2 on all of those terms, and I get negative 5 plus or minus the square root of 5 over 1, or just negative 5 plus or minus the square root of 5. Right? So if it's common to all 3 terms, you can divide it out. So if we had 8 plus or minus 6 times the square root of 3 over 10, let's say. See how there's a common factor of 2 in all 3 of those terms. And so that 2 can divide out, right? Because it's a common factor in both the numerator and the denominator. And that would give you 4 plus or minus 3 square root of 3 over 5. You can divide out the 2. But if it's not common to all 3 terms, then you can't divide it out. Okay, so if we had 6 plus or minus 3 square root of 5 over 2, you see how there is no, the 2 is only common with the 6 and the 2. It's not with the 3 also. Right? There's no common factor of 2 in that term at all. And so this is simplified. Right? There's nothing you can do to simplify this. Don't try to divide out the 6 and the 2 because then you're dividing out a term and you're violating order of operations when you do that. So you can't do that. Right? And the same with our problem that we've had at the top of the screen here, right? The 2 is not common to all 3 terms, and so this one is already simplified also. So make sure that you're careful about how you simplify a number that's got a square root in it, like that one did right there. All right, so wanted to kind of point that out. All right, next problem. And again, shout out if you have a question about something as we're going through this. Oh yeah, and I didn't write this out with braces when I want to do that. Like that. All right, so those are my solutions. All right, next question or the next example I want to look at. We're still talking about the square root method. So let's say we have 8 times x plus 6 squared. And let's say we have plus 32 equals 0. Now this equation is not in something squared equals a constant form. It's not in that form right there. But you can put it in that form. Because we can, you want to get the thing that's squared by itself. So you subtract 32 and then divide by 8. And see, now we have put that equation in the right form for the square root method. All right? And so now we can, so now this one is in something squared equals a constant form. All right, so you definitely want to do that at the beginning. And then you take the square root of both sides of the equation, just like we did before. So you have x plus 6 equals, don't forget the plus or minus, and then this is the square root of negative 4. Now the square root of negative 4 is not real. It is an imaginary number, and so if like on WebAssign, if on WebAssign they're asking you for real solutions, then at this point you'd write no real solutions. But typically what I will ask you to do is find all the solutions to an equation like this, not just the real ones. And so don't forget that we have this imaginary number I that's defined to be the square root of negative 1. And so because I is equal to the square root of negative 1, you can simplify things like this as an imaginary number. And don't forget then that the square root of negative 4 then technically is the square root of 4 times the square root of negative 1, which would give you 2 times I. And so that's how you write the square root of negative 4 is 2I as an imaginary number, right? And we will definitely be working with imaginary numbers during the semester. I want to remind you of that. So when you have square roots of negative numbers, be ready for that, right? That you're going to have something that's imaginary. And then subtract 6. I put the 6 at the beginning, just like we did with square roots, and I would leave the solution as just negative 6 plus or minus 2I. That's an okay form to write solutions like that. And be expecting that that's going to happen sometimes, that you're going to have imaginary solutions. So don't panic when you see that happen. All right, so that was the square root method. The next method we want to look at, we're not going to spend a whole lot of time with this, but I do want to work through an example or two, is completing the square. Now, completing the square is a way of taking an equation where you can't use the square root method and rewriting it so you can use the square root method. In other words, the equation is not in the form something squared equals a constant, but and there's no obvious way on how to do that, but it can be written that way. So like this equation right here, x squared minus 10x plus 8 equals 0. Is an equation that's not in something squared equals a constant form, right? It's not in that form. And it's not something you could easily put in that form, right? You can't just move the 10x and the 8 over because you don't have a constant on one side of the equation. So the way to take an equation like that and write it in that form, in something squared equals a constant form, is to complete the square. So I'm going to actually write that out. So complete the square to write in something squared equals a constant form. All right, so how do you do that? How do we complete the square? All right, so let's walk through the steps. The first step is to always move the constant to the other side of the equation. So you move the constant term to the right side. All right, so that's what we did. Is notice I subtracted 8 from both sides of the equation. Also notice that I left a space here where the 8 was, and the reason why I'm going to do that is because I'm going to fill that in with something else. And what do you fill it in with? You take the middle term, the middle constant, middle coefficient, and what you do is you multiply that by 1/2. And by the way, it doesn't really matter that it's negative. I mean, you can leave the negative in there or not. And you'll see why it doesn't matter in a second. So that gives you -5. So you always multiply it by 1/2. But then you do something else. You take that result and you square it. So you take the middle coefficient, in this case the -10, you multiply it by 1/2, and then you square it. And that is the constant that you will add to both sides of the equation. So you add to both sides. So I'm going to add 25 here, and I'm going to add 25 here. All right, so you make sure you add it to both sides. Remember, that's something you're restricted to, right? When you're solving an equation, you've got to add to both sides of the equation, or you've changed the equation's solution when you do that. Now, the left side of this equation, when you do these steps, the left side will always factor. And it always factors as the square root of the first term, the sine of the second term, and the square root of the third term. Always, always, always will factor that way. That's why you're taking half the middle coefficient and squaring it, is you're trying to force the left side to be a perfect square. And when you go through those steps, you're forcing it to look like that. It's always going to be a perfect square. And on the right side, -8 plus 25 is 17. And boom, notice what happens is this equation is in something squared equals a constant form. Right, and so that's what you're trying to do, is force the equation to be in something squared equals a constant form. And now you can take the square root of both sides of the equation and solve the equation. Now the nice thing here is square root of 17 doesn't simplify, so you can just leave it as the square root of 17. So this is almost done. You just add 5 to both sides. Boom, and you've got the solutions, right? You've solved for x. All right, so this method is called completing the square. You move the constant to the right side of the equation. You fill in the space where the constant was by taking half the middle coefficient and squaring it. You factor the left side of the equation. It's always going to be a perfect square in this step right here. Always, 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 if you set this up correctly at the beginning, if you go through the first couple of steps correctly. All right, so now you can get equations that are a little bit more complicated as far as the first step or two. The arithmetic can get a little bit nastier. So let's look at one problem where the arithmetic's a little nastier, and then we'll look at the quadratic formula, and then we will be finished. All right, so let's say we have this equation, 2x squared plus 8x minus 5 equals 0. And this one's going to be a little bit worse. Still not going to be too bad, but... All right, now remember what I said is you move the constant to the other side of the equation. So that's what I'm going to do here, is I'm going to move the 5 to the other side. So I add 5 to both sides. But now you cannot complete the square if the leading term is anything but an x squared. It must be just a 1x squared right here. Must be 1 times x squared at the beginning. And if it's not a 1, see if you flip back to this previous screen, notice this was a 1x squared right here, right? And so that's what we want at the beginning. It's got to be a 1x squared. All right, so this one's not a 1x squared, it's a 2x squared. So what do? Well, you go through and you divide, you divide every term by 2. So I'm going to divide by 2 here and here, and divide by 2 on the other side of the equation also. And so you have to divide both sides. You have to divide every term by 2. And sometimes, notice what happens is it gives you a fraction. That's why sometimes the arithmetic ends up being nastier. It's like the 5/2 are stuck with it if we're going to complete the square. Now we go through and actually complete the square. So we take half the middle coefficient, which is 2, and then we square it. Remember, take half the middle coefficient and square. And so you get 4. And so 4 is the constant I'm going to add to both sides of the equation. So I'm going to add 4 here, and I'm going to add 4 here. Remember, you have to add 4 to both sides. On the left side of the equation, this factors. So this is x plus 2 quantity squared. And on the right side, you've got, and remember this, by the way, it's a perfect square trinomial. It's the square root of the first term, sine of the second term, square root of the third term. It's always a perfect square, and that's always how it factors. On the right side, you've got to get a common denominator to add these two fractions together. Remember that 4 is really 4 over 1, and so this becomes 8 over 2. Just multiply top and bottom by 2. And so you end up with x plus 2 squared equals 13/2. And then you take the square root of both sides of the equation, because this is now in the form something squared equals a constant. Right? Remember, that's what you're trying to do, is get the equation to look like that. It is something squared equals a constant. And so now you take the square root of both sides of the equation. Take square root of both sides. So when I do that, I get x plus 2 equals, don't forget the plus or minus, and then this is the square root of 13/2. Now, I typically am not going to freak out over the square root of 13/2 if you left it like that on a test. However, like on WebAssign, they will never leave square root of 13/2 in a answer like that. They will always rationalize it. And remember, you rationalize by multiplying, the top and the bottom by the square root of 2, in this case. Right? And so that gives you, in the numerator, that gives you plus or minus the square root of 26. Square root of 13 times the square root of 2 is the square root of 26. But in the denominator, the square root of 2 times the square root of 2 is just 2. And that's why you're rationalizing it, because now there's no square root in the bottom. Like I said, ordinarily I'm not going to freak out over something like that. It's probably something I'm not even going to penalize you for. But WebAssign, you will be penalized for it. So when you're doing your homework there, you have to make sure you rationalize the denominator like that. And then you solve this equation by subtracting 2. So you have negative 2 plus or minus, and then the square root of 26 over 2. If you left it like that, I would be fine with it. But if you need to write it as a single fraction, then you need to get a common denominator, which is 2. Remember, this negative 2 is really negative 2 over 1. And so you multiply top and bottom by 2, and you get negative 4 over 2 plus or minus the square root of 26 over 2 is negative 4 plus or minus the square root of 26 all over 2. And then don't forget, I can't divide those 2's out between the negative 4 and the 2, and so those would be my solutions. So this is a little bit more challenging in a problem like this, and the arithmetic could actually get even nastier than this. Now, I'm not going to make a huge big deal about this. When I test you over this, I'm not going to go out of my way to make something that's incredibly messy, but I do want you to be able to walk through the steps of completing the square, definitely. All right, final thing to talk about in our really brief rundown of methods for solving quadratic equations is the quadratic formula. And so remember, the quadratic formula is actually, a formula, literally a formula, just like the area formula for a circle, where you can solve and find the solutions for a quadratic, right? This is a quadratic where that squared term is there. And the solutions, the quadratic formula says that the solutions are, to this kind of equation, always in this form. X equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And that's our quadratic formula. That is a formula that I expect that you know during the semester. It's never a formula I'm going to give you. It's something that I expect that you can write down and use to solve a quadratic equation when you need to. All right? So just to kind of give you a heads up on that. So, you know, what has to be true here? The equation must be in a form where you can identify the a, b, and c values. So, for example, this equation, 2x squared minus 8x minus 5 equals 0. Now, this is an equation that's not factorable. You could not use factoring to solve this equation, but you could use the quadratic formula to solve it. This is in ax squared plus bx plus c equals 0 form. So, right, this is in that form. And because it's in that form, you can identify the a, b, and c values. And then you're just literally using the formula and plugging those numbers into the formula to solve the equation for x. So you get a is 2, b is negative 8, and c is negative 5. Make sure you include the signs when you write something like that out. All right, and then you literally just substitute into the formula. So you have x equals the opposite of b, right? There's that negative sign in front of the b there. And so b is negative 8 in this problem, so the opposite of negative 8. That's what it says to do. And then plus or minus. That plus or minus is addition and subtraction. And then the square root of, please use parentheses when you write this out, right? This is what I kind of expect that you would write in every one of these equations where you're using the quadratic formula. You use parentheses underneath that radical like that. And so this is b squared minus 4 times a times c. Use parentheses all the way through that. All divided by 2 times 2, like that. Take the time to write that out correctly like that, and it's going to make the arithmetic easier as you go through the problem. So you have x equals 8 plus or minus the square root of positive 64. And then be careful, there's 2 negatives in here, so this ends up being plus 40. Because there's 2 negatives in there, all divided by 4. Don't divide the 8 and the 4 out, because that 8's a term right now. I don't know if I have a common factor or not. And then simplify. And so you get 8 plus or minus the square root of 104 over 4. All right, and so then the square root of 104, believe it or not, simplifies. And so you have 8 plus or minus the square root of 104 is the square root of 4 times the square root of 26. It's kind of yucky to simplify, all divided by 4. And so you have 8 plus or minus 2 times the square root of 26, all divided by 4. All right, and now there is a common factor of 2 in there, right, in all 3 terms, and so you can divide it out. And so you are left with 4 plus or minus the square root of 26, all divided by 2, like that. All right, and that's your, those are the solutions to your equation, and you've solved it using the quadratic formula. All right, so now you've got solutions to the quadratic. and you're finished with the problem. Now, the only thing that you need to be kind of aware of is that sometimes you get imaginary solutions when you solve an equation like this. So you do need to kind of, pay attention to that, and that's going to happen. And, this is going to be my last problem of the day right here. So this is our last problem. All right, so pay attention to the fact that sometimes you're going to get imaginary solutions. So for example, if we have 3x squared plus, let's say 2x plus 8 equals 0. 3x squared plus 2x plus 8 equals 0. All right, so this is already in the right form. To use the quadratic formula, we can identify a, b, and c. And so we substitute into our formula, and I'm going to write the formula down again. Like that. And so you get x equals the opposite of b, so this would be -2 plus or minus the square root of b squared. Make sure you use parentheses, minus 4 times a times c, all divided by 2 times 3, like that. And so you get x equals -2 plus or minus the square root of 4 minus, and then 4 times 3 times 8 is 96, all divided by 6. Right, 4 times 3 is 12, and then 12 times 8 is 96. And so notice this gives you -2 plus or minus the square root of -92 over 6, like that. And since it's negative, right, that number is negative right there, you're going to have imaginary solutions. Right, and that number, by the way, that square root of -92, that comes from the b squared minus 4ac. Right, this b squared minus 4ac is -92, like that. That b squared minus 4ac is sometimes called the discriminant of the quadratic. And if the discriminant is negative, right, so if b squared minus 4ac is negative, you have imaginary solutions. Something that's going to be good to know. Now the square root of 92, believe it or not, simplifies, let's see, as the square root of -4 times the square root of 23 of all things. Right, and so, because 4 times 23 is 92, all divided by 6. And so you end up with -2 plus or minus 2i times the square root of 23 over 6. And then you could go through and divide out the 2's, because there's 2's that are common in all of those terms. And you end up with -1 plus or minus I times the square root of 23 over 3. So it's a little bit yucky there at the end. And so you get -1 plus or minus I times the square root of 23 over 3. And those are our solutions. All right, so very, very fast rundown on all the everything with quadratic equations. What I always do at the end of each lecture is I will assign you textbook homework. The textbook homework is not graded, but this is for practice only. But my recommendation is that you try to do some of this, if not all of it, at least some of the textbook homework on a regular basis. It will help you prepare for exams, definitely. And in this case, the practice homework is on page 129, and these are the problems I'd like you to look at on that page. I will always answer questions on these. So like when we meet again for lecture next Monday, I will be happy to answer any questions that you have. Also, during my office hours, my online office hours, I'll be happy to answer any of these questions. These are always going to be good review problems of what we've covered in class. Remember that you have web-assigned homework. The first web-assigned homework is due January the 30th. And so you have a little bit of time on that, but you do need to get started on web-assigned homework also. Does anybody have any questions that they want to ask me here as we finish up our first lecture? Like I said, I went really fast through this. I'm not always going to talk this fast. I assume that this is all a review for you, or mostly a review, and that you've seen all this before. Does anybody have any questions?
No, sir.
Okay, Anne Marie is good.
I have a quick question.
Charlotte.
Yes, this is the online book, right?
When you are you talking about the homework problems I just wrote down?
Right, the homework problems.
That's from the downloaded textbook. So you have to download the textbook. Don't look at the online book that's available through WebAssign. This is the downloaded textbook. The textbook that's through WebAssign is the exact same textbook, but they don't number their problems on there. So you have to actually download the textbook to see the problem numbers and everything.
Okay, thank you.
You're welcome. Anybody else have any questions? All right, if there's no questions, the only person that I'd like to hang on just for a second that I want to talk to is John. So John, if you would hang on just for a second, if everybody else, you can log out, that would be awesome. And I will talk to you next Monday. Remember, I do have office hours today from 11 to 12. And then again tomorrow from 11 to 12. And then on Sunday from 8:30 to 9:30 in the evening. So don't hesitate to stop by any of those times for questions, okay? Otherwise, have a great day, and our next lecture will be next Monday.
Okay, have a good one.
Thank you.
Thank you.
Thank you.
Thank you. Goodbye.